So let's start today's lesson with a simple question. Why, when an electrical component fails, does the fuse not blow? Well, the reason comes down to the type of failure in the circuit. And most of the time, not always, when a component fails, when an electrical component fails, it fails open circuited. But to help explain this, let's look at a simple injector circuit and walk through the different circuit failure possibilities. So today's lesson is going to be about opens, shorts to power, shorts to ground, and how a circuit normally operates. So I had a viewer ask the question, why, when an electrical component like an injector fails, does it not blow the fuse? And that gave me the idea of this lesson. So let me share the diagram here. And what we're looking at is a wiring diagram of a V8 fuel injection circuit off of a vehicle. And the way, just going to show you some quick things, and then I'm going to cut the wiring diagram in half just for sake of being able to see things in a little more detail, a little more clearly. But in this case, this manufacturer divided their fuel injectors into odd on the left side and then even numbered injectors on the right side. And you can see that power is fed to them, and then it goes through this fuse to each individual injector, all four of them. So we have power going to the injectors anytime the powertrain ignition 1 relay is turned on. Whenever it's energized, it's turned on. And if you don't understand how relays work, check out this video about relays that I made a while back. So as long as that relay is powered, the injectors are going to have power all the time. And then if you look at the very bottom, the ECM, the engine control module, is what's going to be providing the ground to complete the circuit to turn on the injectors. All right, so what I'm going to do now is I'm going to go ahead and just divide this schematic right in half, this wiring diagram right in half right along here. Again, just for ease of seeing things in a little more detail, not quite as cluttered, but the beauty of it is this really is like two separate circuits in one. The left side, the odd injectors, which would be 1, 3, 5, and 7. And then the right side is the even injectors, 2, 4, 6, and 8. All right, so I'm going to go ahead and get rid of this and magically make the odd injectors appear on their own. Isn't that just amazing? All right, so in a normal operating circuit, like I said, as long as this the injector 1 relay up here at the top, which we're not seeing, but we can see that it's what's sending power to this fuse. As long as that relay is active, as long as it's turned on, then we're sending 12 volts through this fuse to our fuel injector. And if you were to get a multimeter or even a test light in this case, now you can't always use a test light. In fact, I would really caution you against using a test light in a circuit that could be computer controlled unless you really know what you're doing. In this case, if we were to use a digital multimeter, we would actually read, or even a voltmeter, a test light. If we were to measure right here at the terminal at the ECM connector, we would read 12 volts. Well, wait a minute, Bill. The fuel injector should be using up the voltage, right? No, only when the circuit is turned on. And y'all, this is something as a technician myself that used to really blow my mind when diagnosing circuits. I would be testing the ground side and wondering why I would have voltage on it. Well, the reason why is the circuit's not turned on. So in this case, if it's a ground switched circuit, all the way up to that ground switch, we will have 12 volts. So that's one quick tip for you when you're diagnosing ground switched circuits. You will have voltage on the ground side of the circuit if the switch is open. So don't let that throw you off of your diagnosis. So that's the circuit as is drawn right now. So what happens when the ECM grounds the injector? So right here at the very bottom on injector number 1, I went ahead and completed the path to ground. So now what happens, we've still got our 12 volts coming from the ignition 1 relay through the fuse up to the fuel injector. And now because we have a ground path, the fuel injector will use up all of those volts. So all 12 volts will be used up right there. And now on the ground side, if we were to check right here on the other terminal of the fuel injector, we would have 0 volts. Why is that? Why did we have 12 volts before and now we have 0? Because electrical things use up voltage. So our injector is using up all of our voltage. We still will have current flowing through it to return back to the battery, but the voltage will get used up right here in the injector. Okay, and that's a normal operating circuit. That's how it should work in normal operating conditions. That's what we'll get. All right, so let's talk about some different failures here. And one of the failures that I was asked about was when a component is shorted to ground. So keep in mind, this circuit, this ground circuit in the ECM is a very, very low current circuit. It's not looking for a lot of voltage to be coming through it because the voltage should get eaten up at the fuel injector, right? So let's say that our fuel injector is shorted. Something happened inside the fuel injector, and now the terminal A and terminal B inside the fuel injector, this is terminal A, this is terminal B. For some reason, something failed inside the fuel injector, and now it is shorted together. Those two terminals, those two circuits are shorted together inside the fuel injector, basically rendering the fuel injector as just being a wire jumping across the top half of the circuit to the bottom half of the circuit. And now, if that was to happen, we would still have 12 volts right here, right? Before the ECM grounds it. But this is what's going to be wild is when the ECM grounds it, the ECM is not looking for a surge of 12 volts. It shouldn't see any voltage there. It may see a very, very, very minuscule amount of voltage when the fuel injector is working, but it's not expecting 12 volts. So most ECMs are going to have some sort of fail-safe circuit protection. So if there is a short to power, which is what this is, then it's going to immediately open the circuit again. It's going to shut that off. So the fuse would not blow because we've opened the ground. We have opened the circuit, virtually stopping current flow, and that would keep the fuse from blowing. I hope that makes sense. Okay, so that's scenario 1. That's answering the viewer's question. But we have other questions. We have other scenarios. And now you're probably thinking, well, Bill, so why have the fuse up there? Why have the odd injector 20 amp fuse up there, which looks like it's fuse 12 in this case? Why even have it if the ECM has this built-in circuit protection, right? That is a very valid question. So let's take a look at this. Since we're talking about short circuits, then we'll look at, so we're going to look at shorts to power, then we'll look at shorts to ground, and then we'll look at open circuits as well. So I want y'all to understand by the time this lesson's over, what a short to power is, what a short to ground is, and then what a short, not a short to open, what a open circuit is, okay? Sheesh, get your act together, Bill. All right. So we talked about a short to power, a short internally in the fuel injector, right? So let's say that, again, normally the way the schematic is drawn right now, we have 12 volts all the way to the ECM until the ECM grounds the fuel injector. Okay, just so we can establish that that is the case, that is true. Let's say that for whatever reason, and y'all, this happens, you'll have someone that doesn't really understand what they're doing, and they're adding, I don't know, an aftermarket alarm system, aftermarket remote start system, aftermarket radio, whatever they're adding to their vehicle, rock lights or whatever it happens to be. And all they're looking for is power. Hey, there's power. So let's just say they've got a test light and they're testing things under the hood, key on, engine off. And hey, this wire right here has 12 volts on it. So I'm going to attach this other wire to it, which happens to have 12 volts also. I don't know. So we need 12 volts full time. We need 12 volts switched. This is 12 volts switched. So it's only has power with the key on. They're hooking something that has 12 volts all the time to it. So now we have a short to power on the ground side. Okay. So we have induced 12 volts in the ground side of this circuit. Is it going to make a difference at this point? The way the circuit's drawn? No, it's no different than what we already have, right? With the injector turned off, we already have 12 volts on both sides of the injector. So there's no voltage dropping across the injector in a normal open, the ECM doesn't have it grounded injector circuit. So there is going to be no ill effect of this. Now, this is where there is going to be a problem. When the ECM grounds this injector, we have 12 volts on the ground side. That's going to be an issue. So now what's going to happen is we're going to overload the ECM, the driver, which is a transistor, okay? And the short circuit protection in the ECM should immediately create an overload, opening the circuit, not blowing any fuses or anything like that. But now you're pretty much going to have a constant misfire because the ECM is doing what it's supposed to do in protecting its circuit. Now, in rare occasions, it can overload the transistor and actually blow the transistor in the ECM. If that's the case, you just got to replace the ECM. So a lot of times when you see like a driver failure code or whatever, the driver is a transistor. So let's talk about what kind of code we would see now, because you probably will see a trouble code come up. Now, off the top of my head, I cannot think of a particular trouble code, but it would be a trouble code saying something to the effect of fuel injector 1, ground circuit high. Okay, so what that means is if you think when manufacturers about 10 to 15 years ago went to a global architecture in their service information, so worldwide they use the same terminology, the same nomenclature for their parts and stuff like that. So they didn't have to write wiring diagrams for US, for Europe, and so on. They went to high means power, low means ground. So if you see a circuit high problem, it means we have a power problem. In this case, we have power where we shouldn't have. And then if you see a circuit low issue, that means you have a ground issue. It's going to ground when it shouldn't be. So keep that in mind. That's a very, very helpful tip there. Okay, so in this case, if we have a short to power on the ground side, the effect will be it won't blow the fuse, but it will cause the overload protection in the ECM to kick in, basically opening the circuit. In very, very, very rare occasions, it may blow the fuse. But most of the time, the ECM is going to override it, open the circuit, and stop the fuse from blowing. Okay, so we talked about a short in the component. We talked about a short on the ground side. Now let's talk about a short to power on the power side. So if we were to have a short to power here, what kind of problem would we expect to see with that? Right? Basically the same thing, except we're not going to have an overload protection problem because it's already got 12 volts there. That is an absolutely normal condition. And with the key off, the ECM doesn't ground the injector anyways. So this would be probably the best case scenario is the positive side of the injector control have a short to power. It's really going to be pretty much inconsequential. It's really not going to cause any problems that I can think of at this point. So we've looked at all the scenarios for a short to power. Shorts to power are extremely rare. And usually, like I said, they are self-induced. They are induced by someone hooking up something they shouldn't have, or someone that's adding an aftermarket component and they just don't really know what they're doing. They don't understand electricity or wiring diagrams. So shorts to power are pretty rare. So let's look at a short to ground now. Okay, shorts to ground. So let's look at a short to ground on the ground side. All right, so let's say that in this happens fairly often in a bunch of different circuits. So if you think about all the metal things, metal brackets, the engine block, transmission, there's a lot of metal things that wiring harnesses can rub on. That's why manufacturers use the conduit and the tape around the wires to protect them from getting rubbed through. And the wire looms that they run through also to protect them from vibration and vibrating against something metal that will rub through the wires. So let's talk about a short to ground on the ground side. Okay, so if we have a short to ground on the ground side, what is that gonna do? So with a short to ground, what you've got is you're basically doing the job of the ECM. So the ECM only grounds that injector when it's time to ground it, to give a little spray of fuel into the combustion chamber so that it can be ignited by the spark plug. But in this case, if we have the fuel injector grounded all the time, as long as the ignition one relay is on and we're getting power to that fuel injector is going to spray like crazy. So that's going to flood your engine. It's going to cause a misfire. And that is not ideal. Okay. So that's a short to ground on the ground side. Now, if we have a short to ground on the power side, what's that going to do? So this is the scenario where 100% of the time, if we have a short to ground on the power side, we will blow that fuse. Okay, so that's where the odd injector fuse will definitely blow if we have a short to ground on the power side of any of these injectors. I realize I'm picking on injector one a lot today, but any of these other injectors, it would be the exact same thing. Okay, so that would cause a blown fuse. And then you just have to narrow down, hey, which injector is it? But now you can understand, hey, if I've got an odd injector fuse blown, we've got a lot of wires. We got a big circuit to look at. Where are we going to look if we have a blown odd injector fuse? Well, you can pretty much eliminate the bottom half of this circuit and know that our problem is going to be up on the top side. So that helps you narrow down the scope of what you're looking for. So if we know that we have a blown fuse on the injectors, then we can eliminate the whole bottom half of this wiring schematic and focus just on these few wires here. And it's a lot less that we'd have to look at. And the more you can narrow down your search area, the quicker your diagnosis and your repair is going to be. All right, so we've talked about shorts to power. We've talked about shorts to ground. And now let's talk about open circuits. So an open circuit is kind of, they're pretty common as well. And it could be any number of things. It could be a terminal that someone jammed a test light in, spread that terminal open where it's not making contact. That happens a lot. It could be just a cut wire by accident. Someone was accidentally, hooking something up. They cut a wire and it was open circuited, or the wire could have just rubbed through, again, the engine block, a bracket, or something like that. And now the wire is cut all the way through, creating an open circuit. So to understand what an open circuit is, let's talk about a closed circuit. So a closed circuit is basically power, right? So we got a power source up here that's coming down all the way through the circuit to ground, and then going back to be into the battery to be recirculated back through the power. Hope that makes sense. So that a circuit is a complete circle. So think about the battery right here, positive, negative. It comes from the positive, goes through whatever device we have here, and current returns back to the negative side. That is a closed circuit. That's what we're wanting to see when we're wanting something to do some work. So an open circuit is whenever there's a break somewhere and the current is not able to, the electrons aren't able to flow all the way back through to the battery. Okay, so I used an injector circuit for this, but this can be applied to any circuit on the vehicle. This could be a blower motor. Rather than a fuel injector, this could be a blower motor. This could be a door lock actuator. This could be a power window motor. This could be a headlight, a tail light. This could be anything that does work in a circuit, and it's all going to be applied the same. Now, not all circuits are going to be ground switched. Some of them, the circuit is grounded all the time, and the switch is on the positive side. But the question was about fuel injectors, and usually they are ground switched. And so that's what I wanted to talk about today. But the same conditions apply whether it's ground switched, power switched, whatever, opens, shorts to power, shorts to ground. So I hope this helped out. If you're wondering, Bill, how can I learn more about wiring diagrams? This was a great video, but wiring diagrams just blow my mind. Be sure you check out my wiring schematics video right here. It will help introduce you to wiring diagrams, how to read them, how to understand what you're looking for, because what you're looking at, because there's a lot of symbolism and stuff like that. So I appreciate you watching. Thank you so very much. Be sure to check out my other videos. I thank you very, very much for your time and attention. Take care. See you next time. Until then, I'm Bill, and this was Bill Teaches Automotive Technology. Take care, everybody.